All right, it's 9 o'clock. I guess we'll go ahead and get started. I'd like to welcome everyone back to our monthly webinar series. This month we're going to, and there you go, should have turned that stupid thing off. But this month we're going to start out with merging inroad surfaces. Chris Congleton is going to show you guys how to take your design surfaces and incorporate LiDAR data into that. And then Patrick Stone will be showing us how to incorporate surface ditches into your templates. First off, though, I want to launch a poll real quick. Just to kind of see how many repeat offenders we have this month. If you guys don't mind filling that out real quick. And that's good enough. We got some news out there, some first-timers. I forgot to mention this last time, and for anybody who's new to this, I just wanted to point out that we are giving training credit for these webinars, but you have to have signed up under your name and your contact information to get the credit. So if you're in a group, in a conference room somewhere, whoever signed up is the only person we can give credit to. And we'll send those certificates out hopefully pretty soon after this is done. If you guys have been watching the slideshow here, let's get that over there. We threw up an upcoming schedule. We've got another HECRAS webinar hopefully coming up soon. Partnering conference kind of threw us off and project deadlines and everything here. So we're going to do that eventually sometime. Stop. There we go. We're going to try to do that one sometime and talk about how to de-skew your bridge sections and inroads. And then October 15th will be the next monthly regularly scheduled webinar, and we'll go into Google Earth, how to get your microstation data into Google Earth. And then we've also seen some issues with the estimator files that PS&E is getting, and so we're going to take a little time to talk about what we need for them to be able to import that stuff into transport. And then I threw this down here at the end, November 6th. We are kind of reincarnating the high dugs. If anybody out there is old enough to remember those, they're a little short, not quite a full day, kind of like a seminar. And we're going to have the first one here in our auditorium, go through some sessions. We're still finalizing topics. More information will come a little bit later once we have the agenda finalized. I just wanted to throw that up there. We have invited consultants to that in the past, and typically it's for cabinet personnel, but we'll see how the agenda shapes up, and then we'll let everyone know, if we want to do half a session for consultants and half for the state only or whatever. More information coming, basically. Chris, are you ready?
I'm ready.
All right, I'm going to give you control, and Chris will take it away and talk about merging surfaces.
Okay, welcome everybody. I hope you all are having a good day today. My name is Chris Congleton, and I'm actually going to be showing you how to merge two surfaces together, specifically a LiDAR surface, which the beautiful Wendy Southworth actually showed us how to create a couple weeks ago, and an existing survey surface, which is something that you get from your survey team. Basically what we want to do first is we want to go load up all of our preferences and stuff, which I've actually done already here. And firstly what we want to do is we actually want to take our existing survey data and we want to make a copy of it. The quickest and easiest way to do that is to right click on that. The reason we want to make a copy is because we're actually going to be changing the surface itself, and we don't want to retain those copies in our existing survey surface. So you right click, you click copy, and you actually show that the name is coming from the existing survey. I'm going to call this simply copy existing survey, something simple so that, and something obvious, and then put the description there. Oops, my typing went crazy. copy of existing survey. And our preference will be existing ground. And then click apply. Close. And I'm actually going to do the same thing to our LiDAR as well, just so that we, technically speaking, we aren't going to be doing any changes to it, but I don't want to do any changes to it. So I'm going to actually call that copy LiDAR, and we'll just leave that existing ground and click apply as well. And what we want to do now is I actually want to close our original file, so we make sure that we don't make changes to them. So I'm going to close. I do want to close it, yes, and I want to free it. So free. Close again. I'm going to do the same thing with the LiDAR. Close. Yes, I want to close it. And my LiDAR free. And there we go. Close it again. What we want to do next now is we actually want to take a look at our exterior boundary of our existing survey. So we go to Surface, View Surface, Perimeter. It's our exterior boundary of our existing survey. And we click. No, we don't want to look at LiDAR. We actually want to look at our existing survey. So we click Apply and Close. Now it's not showing up, so we go to Extend All. Uh-oh. Actually, I have a lot of stuff up there, so let me delete all this white stuff here. Get rid of that, and it'll just show our existing boundary there. So here's our existing boundary. What we want to do is we actually want to create an offset of this boundary to create a buffer zone, or a new boundary that would be essentially a buffer zone between our LiDAR surface and our existing survey surface, so that we have a nice smooth transition between the two surfaces. To actually create that boundary zone, or that offset buffer, we go up here to a Manipulate tool, and we do a Move Parallel. And you can do it by distance, and whatever distance you choose is kind of, you may have to play around with this and do this a couple times, but it can be anywhere from 1 feet to 20 feet to 30 feet, depending on the differences between your two surfaces. In this case, I'm going to go ahead and choose 10, just because it's a nice round number. And we want to keep the original. I do that for myself so that I know that the boundaries have changed. So because I make mistakes, and I just want to make sure that the boundary has actually extended that 10 feet. So I'll actually select the boundary and offset it 10 feet. Left click again, and it'll be offset. And then we right click to get out. So we actually now have a boundary that has been offset at 10 feet. What we want to do now, though, is we actually want to go back, and we want to check and make sure that we don't have any weird things going on with our new boundary, because that's actually going to replace our old boundary, or perimeter, I should say. So let's take a look here. We actually, right off the bat, we can see that we have a problem here. And we have some crossovers and things like that that'll definitely make triangulation difficult, especially right in there. So let's delete some of these vertexes so that we can get a nice clean boundary. We can actually go up to Modify to do this, and delete vertex. And let's delete this one right here, and that one right there as well, and then let's delete that one, and that cleans that up a bit. Let's go ahead and continue on down around our boundary and see if there's anything else. There looks to be one right here that's messing up a little bit, so we'll clean that one up as well. And let's see if there's anything else out there. Actually, I happen to know that there's one right here because I've done this before, just like pulling the cooked food out of it on the Food Network. And that right now, I happen to know that that's all the problems we have with this boundary. But you want to go around and check the entire boundary and make sure everything is okay there. The next thing we want to do now is we want to import this boundary to our copy of the existing survey. And to do this, we actually go to File, Import, Surface, and this is the box that comes up. And we want to make sure we're actually copying to our copy of existing survey, which is what we want. We want to load from a single element, which the single element is going to be our new boundary. We want to use a drape surface because we're going to drape this boundary over top of the copy of our LiDAR surface. We also want to, so basically it's going to hug the LiDAR surface so that it makes a nice smooth transition like we want to. And then we actually want to rename it. I'm just going to call it Buffer, not B-U-F-F-E-R. For some reason my keys are working weird. Anyway. And then we actually want to do the feature style of exterior boundary. Way down there. And we do a point type of exterior. One thing we don't want to do is we don't want to exclude it from triangulation. We actually want it to be included in triangulation. Otherwise, you get some problems with it not actually seeing the new boundary. So we do want to keep it in the triangulation. Once we do that, we click Apply. It's asking if we want to retriangulate, and yes, we do. So go ahead and click Yes. It's asking for us to identify the element that we want to do. So we actually select the element, and then it's asking if we want to accept. Yes, we do. So we left click again, and then we click Close. What we want to do next now is let's take a look at our triangles and see if our boundaries actually moved. But before we do that, I actually want to take a look at, to make sure that our boundary has actually been placed in our existing, not our existing server, the copy therein, I should say. So to do that, we actually go to Surface, Feature, Feature Properties. If we look down through there, there's Buffer, that weird name, and it actually highlights our exterior boundary, which is good. That means it actually is in our surface. Our primary style is exterior boundary, and our feature type is exterior, which is exactly what we wanted. So we'll go ahead and close. And what we can do now is we can actually triangulate our new surface and make sure that it's actually approaching the boundary. To do that, we go to Surface, View Surface, Triangles, and we're looking at our existing survey, or copy of our existing survey. Click Apply. It's asking if we want to retriangulate again. Yes, we do. And there we go. We actually have it to where it actually shows up going to our new boundary, not our old boundary. So everything worked out well here, and that's what we wanted to happen. So now we can actually delete all this, and we can actually merge our boundaries together. So I'm going to go ahead and delete this. Some people may do this a different way. I don't know. I get used to doing it like this, but I'm going to go ahead and delete everything. Close this out. And let's go ahead and merge our two boundaries. To do that, we go to Surface. Edit Surface, Merge Surfaces. And don't worry about all this back here. I used to get really weirded out by all the yellow stuff. Don't worry about it too much. One thing we want to do, though, is we have an original surface, and a design surface, and a destination surface, and things can get confusing. One of the things I wanted to point out is all these boxes that pop up in MicroStation and Inroads, they always have a help key. And they can explain to you what each button and each feature in the box is actually describing to you. It's incredibly helpful. It helps me all the time. I can't remember all the things that Microsoft does. But if we're looking at this, we're actually looking at surface. Which should be our original surface, the LiDAR or the existing survey? It says that in this case, it specifies the name of the surface containing the data that is to be merged with the design surface. Our design surface is going to be our survey, because we're actually doing the design based on our most accurate information. So our survey is our design surface. So we know from this, and looking at it, and kind of the descriptions therein, how to determine which is which. So in this case, we're actually going to do our original surface to be the LiDAR surface, and our design surface to be a copy of existing survey. We want to name our surface something simple. I use merge, not merge, but merge. And we don't really want to retain all the surface points because, well, there's really no reason. We don't need to retain the features excluded from triangulation. Merge select areas from original, don't really need to do, but definitely what we need to do is add design surface as the edge of the break line, because we don't want those triangles crossing over our boundary line. We want a nice, smooth transition there, and that's why we created that buffer zone in the first place. Once we do this, we go ahead and click Apply. And you didn't see it back there, but it was thinking about it. And go ahead and click Close. And now let's take a look at our surface. Let's go Surface, View Surface, our new surface, our merged surface. And we don't want to look at the LiDAR, we want to look at Merge. See, we now have a merged surface selection coming up there. And click Apply. One thing it's actually thinking here, one thing I would like to mention as this is happening, a lot of times our surfaces will be very large. Whenever you see this happening, this processing, you want to give it time, because it's going to be very, very difficult sometimes for these large files to process. For us to let's take a little easier look at this. Let's go to a smooth view of this surface, and we can zoom in on it. Let's do a rotation. Let me reduce this so we can take a better look at it here. Actually do our view tool. We'll do a dynamic view here. Look how nice and smooth that is. I can't see any difference between where our original boundary began of our existing survey and our LiDAR surveys began. I mean, it's smoother than a baby's bottom. Well, maybe not a baby's bottom because of all this stuff, but it looks really, really good. So let's go ahead and put that back to top view. I'll do that up here, actually. And I'd like you to take a look at a surface in which the merge wasn't done with a buffer zone. We basically just took the LiDAR and the existing survey and just merged them together without doing any buffer, any transition whatsoever. Let's go ahead and close that. And that's our bad merge here. I actually created it earlier. So let's view surface, triangles. And we'll look at bad merge this time. Click apply. Again, we're waiting for it to process. Try not to click any buttons and stuff when this is going on, because MicroStation gets fussy and En-ROADS gets fussy and it gets angry and it doesn't really like to do that kind of thing. So close. Let's go ahead and reduce this down again so we can take a better look. Pull it over here. And right off the bat, I don't know if you can see it there through your all screen, but I can see the border of that existing survey. If we actually do a rotation of it, let's get in here right on the border and rotate it around a little bit. You can see a big fat edge that comes down and drops right there. And we're trying to avoid that with that buffer. That's why we actually created it, so that and in this case I probably didn't have to have 10 feet, but you know, it was a nice round number that I used. But that's not too much of a lip there. But at the same time, it's something that's going to show up in your profiles, your cross sections, and whatnot. Not your profiles, but your cross sections, and we really don't want that to happen. So that's the whole reason we do this, and that buffer zone issue. But from that point, I would like to show you one last thing. There's definitely for your KYTC users, there should be a tab at the top of your MicroStation link in which you can actually click on it, go to Kentucky Cabinet, and go down to your software and support. And it'll actually pull up a web page. We can bring over, well, having some technical difficulties here. Okay. Well, and I've got a blank page here. Let's try this one more time. There we go. Now it's connecting. Good. But this will actually take you to a page where you can actually get help for things. In other words, basically, here's our webinars. We actually show our webinars. This is the webinars we've done in the past. We post these webinars on this web page. Here's merged surfaces. This is what I'm doing today. It's actually a workflow of everything that we're doing. So you can actually print those out and actually follow along if you want. If you are not with the Kentucky Transportation Cabinet and you don't have this little tab on your MicroStation, you can go to the Highway Design web page, which I'm going to go to here. This is our Highway Design web page. So type in Highway Design KYTC in Google search or whatever your search engine is, and it'll bring you. It'll definitely bring you here. And to get to that, all you have to do is come down here to Resources, Software and Support. It'll take you to that page, and you can find all these things again. It's incredibly handy. It's incredibly useful. These workflows are great. They're usually very well detailed. And again, the webinars are excellent as well. These are past webinars that we've done before. With that being said, that's everything I've got. Do we have any questions today? I'm going to turn this over to Kevin.
Right now, we don't have any questions, so you can go ahead and switch over. Let Patrick take over, and then if you guys have any questions on either one of these, type those in the questions box, and we'll get to them at the end of the webinar. Hopefully, we'll have some time at the end.
Okay, well, I'm going to hand it over to Patrick then, and we'll have Patrick on here in just a second. Thank you all for your time.
Whenever you're ready, Patrick.
Okay, I'm just getting set up here. I can load some.
Forget to load your preferences.
Okay, I'm Patrick Stone. Today we're going to be talking about incorporating surface ditches into templates, and basically what we're going to be focusing on is building the 2-foot flat bottom surface ditch from when you're in a cut and in a fill. We're going to be using version 8.11.7.540, which is what the standard the state's using right now. First thing I want to do is show you we have some templates already set up that you've probably been using in our delivered workspace. And this is basically, but what we're going to do is we're going to be creating this surface ditch, show you how this was created, and we're going to have the conditions that when the ground line is sloping away from the road, we're going to catch that water also. And let me just show you how this one was set up to work. It does have a minimum depth on it for 1 foot. And if you've placed the surface ditch and you've ran it through your template and it has not failed, it's because you didn't meet the minimum depth. I mean, it'll run through all these different alternates, but that's why it didn't work. So what I want to show you is this one works great when you're at a 0%, or if you're at a 10%, or a positive percent. Anytime it's catching that slope, it's going to work, and it's set up to do, multiple slopes. But what we're going to do is we're going to create that, and we're going to add another component to it so it'll catch in the scenario where you've got like a negative. If you had a negative 10% on this, See, it doesn't work. If you had a -1%, anything to the negative is not going to work on this template. So you're not getting anything. And I'm going to show you how to add another end condition to fix that. So what we're going to do here is we're going to create a new template. And let's just name it fill ditch. One foot minimum. And I like to use the dynamic settings toolbox when we're creating these templates. It's pretty handy. I like to set the step to 1, just so I'm not snapping to something. That'll get you the basically a 1 foot grid, and you can snap around and get, you're going to get the 1 foot grid increments. See how it's changing right here? Like when I click down there, it wouldn't let me go to a half because I've got that set to 1 foot grid, and then it'll tell you where you're at on that grid. Anyway, that's the way I like to work. I want to point out that these point names have the styles associated with them. So when we go through here and we set up like shoulder, you're going to automatically get the properties of that shoulder, the point style, the features, and everything. Now the apply fixes, what that's usually used for is when you want to put a fix on there of left or right. When I'm building one of these end conditions that I'm going to use on the right or the left, I don't apply fixes. That way when you drag this in to build your template, you can add right or left. And that will help you keep from having right, like your shoulder right. And then if you've mirrored that to the left with the fixes, you can get like a shoulder right left. And when you're editing those features and trying to manipulate some of those features in your surface, it can cause you problems later. So another thing I want to point out, you've got help on all these inroads commands. If you just hover over this or click on it and hit F1, it's going to take you to the help in inroads. And this works for all the inroads commands. And what we're going to be concentrating on are these keyends, and it's got a list of the different keyends you can use here. I'm not going to bore you reading them all, but F1 is your friend when you're in inroads. I want to point out this dynamic origin too. This dynamic origin right now is set to 0, 0. And you'll see when we're drawing the surface ditch and we've got some temporary points, we're going to need to change that dynamic origin. And we want that to be referenced to like the shoulder point, or that's the way you reference points from different dynamic origins. I want to point that out. But what we're going to be using, what we're going to focus on today is we're going to be using the keyends, and we're going to use horizontal slope, HS, vertical slope, VS, and then we'll use an origin slope so you can see how that works. And the first thing we're going to do is create a berm. The Kentucky berm. So what we're going to do is we're going to add a new end condition or component end condition. Now the way I've been doing these is it'll pop up down here and you name your components down here. And not to worry, if you mess one of them up and you don't get the name, we can go back and I'll show you how to change those properties at the end. But I found it a little easier to go ahead and name them now. So the first thing we're going to do is call this one, let's call it berm or fill. Let's call it fill. We want to set the style of this to proposed fill component. And if you haven't messed with these styles in a while, these components, I think we've had them out there for 6 months, maybe a year. What that's going to get you, if you'll use this style, when you're looking in your model, you run your model and you look in the 3D view, you're going to get the component styles that are assigned to that. So you can get the grasses or the concrete or the asphalt patterns. But anyway, first thing we're going to do, we've got that set up. We want the target type will be surface. I want to set this as priority 1. I'm not doing benching. I'm not going to worry about any of these offsets at this point. The first that we want to place the shoulder point. So we have a shoulder point placed. Now we're setting this berm. What we're going to do is go down through here, and we're going to set a 15-foot vertical on a 1 to 3. And then I'm going to show you how to construct the berm. We don't want to apply fixes. We do not want check for interception at this point, and I'll explain that to you. I'll show you the priorities in a little while. I'll show you why. We're going to set that to vertical slope. We want it to go down 15 foot. We want it to be on a 3 to 1 slope. Let me change this point to berm before I mess that up. Now we've got the berm set. Now that was based off the shoulder point. The next thing I want to do is I want to set the dynamic origin, and you can tell the dynamic origin from this blue, I don't know what's showing up on your screen, but this box right here is your dynamic origin. And we want to set that up here to the shoulder for this particular point. And we're not going to check for interception. The end condition is not infinite. We will come back and turn on the do not construct, but just to show you how this thing works, I'm going to leave that on for right now. Now this point will be a temporary point. And I'm going to use the offset, the origin slope. And we're going to make this berm 10 foot wide on a 12 to 1. Now what we're going to do is come in here and place, we're basically mimicking this slope. So we're going to come over here and set this to, I'm going to call it the ditch 4 slope. And we do want to check for interception. We want to place the point at the interception, and the end condition is infinite, because I want it to seek the ground now. We'll use vertical slope. And we'll do the same. We'll go 15 foot down on a 3 to 1 slope. Now we're going to finish that. Now I'm going to show you how the priorities are what we have to, and constraints are what we have to change on this particular end condition. And I want to show you how those work. See, these are all constrained. This one's to temp, temps to berm, berms to shoulder. So if you test that right now, you can see what that's going to do. You know, it's not what you want, and it's because we need to change the constraints. This is the way this constraint, as I just said, you can turn on constraints and see it. But what I want to do is I want the temporary point constrained to the shoulder. And these should automatically update as far as your values. Now we want it to be horizontally 10 foot off there, and then we want to set this to slope. And that is what we want right there. And now we're going to go down here, and we want the berm constrained to the ditch 4 slope. And we want that set to slope and horizontal. Now let's test this. That's not exactly what I want. Oh, we need to turn the do not construct on that. Let's see. I'll show you that one more time. If we turn the do not construct, what it's going to do is it's going to come down and find the point down here and connect that one. See, now you've got your first part of your slope. And that's what you want with that. Now what we're going to do is we're going to come in here and we're going to add another end condition, and we're going to put a 2-foot flat bottom surface ditch here that intersects the ground. And this is how the one that's delivered, the fill ditch, was created. So let's create a new end condition. We're going to call this one, I guess we'll call it just minimum ditch positive. We want this to be assigned to the proposed ditch component. So again, we can get our, let's see. There we go. So we can get our surface features and our materials. We're going to set this to priority 1. And it's going to assume, if you pick here, see how it's locking on DFS, it's going to take that point name. So you can type in another name here if it makes you happy, but it's going to take this DFS. So just pick on that one. Now we're going to set our next point, and it's going to be the ditch foreslope. We do not want any of this checked on because we're going to give it specifics on how we want this ditch constructed. And if you turn on end condition is infinite, it's going to seek and find the ground line or fail. We don't want that. We're going to use vertical slope again. We want to go down a foot, and we want that to be on a 1 to 3. Now we're going to set that to the ditch bottom or ditch back slope. We're going to set that to horizontal slope. We want it to be 2 foot on a 0%. Now we're going to go up and intersect the ground line. And on this one, we will want to go in and change this. We want to set it to check for intercept, place pointed interception, and end condition is infinite. Now we will change that to a cut. And we're going to want a vertical slope on that. And on this one, let's go up 3 foot on a positive 1 to 3. Now let's take a look and see how this one works. See, now you're getting your ditch all the way up, so it's following the ground line. That's going to work just like the one we'd already had set up. Now, if you set this to a 5% negative, see how it's not a foot deep? We're going to have to go back and add a minimum depth to this one to make this work properly. Now, if you were at a 5% to the positive, you're going to get your 1 foot minimum because it's based off this point right here. So what we're going to do is go in and we're going to add a minimum depth point, a temporary point that's going to be placed along this line. And we're going to tell it, don't succeed unless we accomplish a foot deep here. And you can change that to whatever suits your particular job. So what I like to do is insert a point. And I won't be using this. And it's putting cut 1 on there. That's not what I want. I'm just going to place a point there and modify it. This is the easiest way for me. Let's go down here and pick the temp point. We don't want display. We don't want to check for interception. And we're going to turn on the do not construct. So we don't want that point showing up in our model. Okay, and how we're going to constrain that is we want it vertically constrained from ditch bottom. We want it to be a foot. I'm going to constrain this with the vector offset. We're going to do it between ditch bottom and cut. And the reason for that is if we go back in here with parametric constraints and we change the slope, I want this point to follow whatever the slope is. So what we'll do is we'll make it from ditch bottom to cut. And we want to set that to 0. Make sure that's set to 1 or whatever your desired depth is. Apply. Now we're going to test it, and it works just like it did, as long as you do the positive. When we go to the negative, we don't get anything, and that's what we want. We want this to fail because it's not a minimum depth. It doesn't meet it. So what we have to do at this point is we add another end condition. And that's what we're going to do now. We're going to go down through here. These will be all temporary points down through here because I do not want them to display. So we will add a new component, end condition. And on this one, I'm going to call it, let's call it temp. And I like to do that just so I'll know, if I have problems, I'll know which points were the temporary points and where to start looking, because this is usually, if I make, when I mess one up, this is where it is. I'm going to set that to uncontrolled because I don't want it shown, but I'd like it to show up in like a white or something that I know it's a uncontrolled feature. And this priority, I'm going to set it to priority 2. I want it to search for this one first. If it doesn't find it, then I want to try for this one. And I'm going to leave all this the same. And we're going to come from this ditch 4 slope. And like I said, when we pick this point, it's going to assume that point's name. We're going to merge those points. That's what we want. Let's change all this to temp. We're going to set this point, and we're going to leave. We'll go back and turn this do not construct off, but I want to show you how this works before we do that. So on the vertical slope, we're going to go down 10 feet because we want to get down below the ground and come back up and hit the ground before we actually, we're going to run down this slope, basically construct this ditch 10 foot down here, and we will be starting from this point that it intercepts the ground line and coming back to accomplish the minimum depth here. So we're going to go 10 foot down on a 1 to 3. Now we're going to go a horizontal slope, just like we constructed earlier. We'll do vertical slope. We want to come back up. Now this is going to be a little bit different from this because we're going to come back up this direction to intercept the ground line. So we want to check for interception, place point in interception, and end condition is infinite. As we want it to seek that, it's got to find it. So we'll do a 1 and a negative 1 to 3. And we're going to hit finish. Now we're going to test this. We're already set up to negative, so it should start picking up this white line, this white feature, and see how it's coming back up. It's coming down here, just like I told it to do for the 10 feet, over, back up, intercept the ground line. Now we're going to start our actual, we'll have to change this and make this a component. The next one's going to be a component that will come in and draw our surface ditch, and it'll end up here. And I'm going to leave that these all sets of temporary until we're completed this. So the next thing we do is add a new component, and we want a constrained component. And I'm going to name this component cut. I think cut will be fine. And we will deliver these. We'll deliver these after we get done with the webinar. We'll stick this out for the consultants to get, and the in-house people should be able to get it late this week. Let's just set this. We want this to be proposed cut component. The first point we're going to place, we're going to call this one just cut. Let's be at the same point as that. Now we're going to come around, we're going to find the ditch bottom. So we'll change this one to ditch bottom. We're going to go a -1, 1 to 3. We're going to do a horizontal slope. So we're going to go 2 foot negative, a 0. And I should have changed that name. We can go back and change this name here in a second. That one actually should have been called DF, because you're going to want those to all line up. We'll go up here, click that in, and I do not want a closed shape there. So now we'll finish it. I'm going to change this point name because I'm a freak. And that's going to be the ditch 4 slope. And we want to set this point. We don't want it being displayed unless this temporary one is. So we assign the parent component as temporary, and it won't display unless that was displayed. So now we're going to test this. And now if you do a 5%, so now if you're in a cut or a fill, you're going to get a ditch like you wanted. Now what we need to do is go back, and we're going to change these to do not construct. And now you're getting, let me show that negative so you can actually see it working. Now you're getting that ditch there. It's always, let's see, you can see it's always a foot deep, just like this one was up here. So that's how you build the ditch. Kevin, do you want to see if we've got any questions, or do you have any questions yet?
Yeah, if you guys have any questions, go ahead and send those in. I do have one on merging surfaces. Doesn't matter who wants to take that one, but the question was taking LiDAR out of the equation. You want to merge your proposed design surface with your existing survey surface. Do you have to have that buffer zone around it like you did with the LiDAR surface?
You wanted, Chris, you want to?
What was the question?
Who do you want to answer that? Hold on a minute. Let me let Chris answer since he is.
Okay,
Well, he can't hear anything yet.
Okay, what's the question?
You got your ears on there, good buddy?
I got them on.
All right. The question was, merging surfaces, take LiDAR out of the equation completely. And you've got your existing ground surface and you've got your proposed design surface, and you want to merge those two together. Do you have to have that buffer zone around them to get it to work?
You don't have to have it to get it to work. I showed it where it'll actually work. But if you want them to have a smooth surface in between, it's a good idea to have that buffer zone. Because no matter what you're measuring off of, if it's a DEM, a LiDAR, or whatever, there's going to be a difference in those surfaces, and that difference is going to be corrected through that buffer zone.
Okay.
So I mean, if you can do it and it's flawless, I mean, yeah, it'll work. But I've never heard of that happening. Let's just put it that way. I hope that answered the question. Anything else?
That's the only question I got. So.
Okay.
Unless there's anything else, we'll wrap this up. We'll get training credit out to everyone who attended. When we close this, hopefully a survey will pop up. Give us your feedback. Definitely tell us what sessions you want to see on here, because that's how we're picking the schedule going forward. So please give us your feedback. And if we get done here and you have a question, you want to talk to somebody directly or email us, you know how to get hold of us. Go to the support page, and it'll give you all of our contact information. I'd like to say I appreciate Chris and Patrick today for helping us out and showing us a few things, and I hope you guys learned something. And we'll see you back here next month.